everybody, let's talk about solving a system of equations by, elimination. So at this point, you should know how to solve a system by graphing, by substitution. This is just yet another method, elimination. So if you know how those other methods that I just mentioned work, this one's not too bad once you get started. So the goal of elimination is to eliminate one of your variables. Reason being is if we look at this first problem, we have x's and y's. We can't solve this, and we can't ever solve it and figure out what x is or figure out what number is for y. So our goal is to eliminate one of the variables so that we only have, say, y's left, or we only have x's left, because that makes it a lot easier for us to solve. Now, how would I even know that I should be doing an elimination problem? Well, the graphing problems you typically see like a y equals as one equation, y equals for the other one. For substitution, we talked about how you'll see like x is alone or y is alone. For elimination, you're going to have no variables by themselves. You're going to see your x's lined up and your y's lined up, though. That typically tells you, hey, we should be doing elimination. So you're not going to see an x equals, you're not going to see a y equals. So that's how we know we're going to do elimination. So let's get to it. I want to try and eliminate either x or y. So what I'm going to do is I'm going to add straight down is what the goal is. And when I add down and combine the like terms, the x's with the x's, the y's with the y's, the constants on the right side of my equal sign with the other constant. And what we want is we want variables to eliminate. So I have 4x minus 4x. If I combine these two, 4x minus 4x, that goes to 0x, which is 0, which means the x's eliminate. That's what we're looking for. We're looking for the same number in front of the variables, except one needs to be positive and one needs to be negative. So this one's already set up really well for elimination. We'll look at what do you do if it's not set up here in a little bit. But this one's set up really well because I have a 4x minus 4x that if you add straight down, that is 0x. Those eliminate. They're gone. For my y's, I have 8y plus 2y, which is 10y. And then I have my equal sign, and then I have 20 minus 30, which is negative 10. Just like that, I've gone from two equations with both x and y, to just a single line only with one variable left. So what I can do is I can now solve this for my variable that I have left. I could solve for y, which means I'm going to divide by 10, which means I get y equals negative 10 divided by 10, negative 1. Our goal, remember, is to figure out the coordinate for where these two lines intersect, and I now know the y part of the coordinate is negative 1. So all I have to do is figure out the x value. So what I'm going to do is I'm going to take this piece of information I now have, plug it into either of these two original equations. It doesn't matter which one. You could pick the top one, I could pick the bottom one. We'll get to the same answer. So I'm going to use the top one. 4x plus 8y equals 20. And I'm going to take this y equals negative 1 and I'm going to plug in for y. So I'm going to have 4x plus 8 times negative 1 equals 20, which 8 times negative 1, that is negative 8. So I have 4x minus 8 equals 20. Move that 8 to the other side away from the x. And we have 4x equals 28. Divide by that 4, divide by 4, and x equals 7. So I found my x, I found my y value. This is where these, remember these are two lines crisscrossing, and this is the coordinates in which they crisscross. I could always check this answer by taking my x of 7, my y of negative 1, and just plugging them in and checking those solutions. So that was a basic example of elimination. Let's show you a little bit tougher one. So down here I have a system of negative x minus 7y equals 14 and negative 4x minus 14y equals 28. Again, I need to eliminate either my x's or my y's. Right now, that's really like a negative 1x there. I have like a negative 1x and negative 4x, which that's negative 5x. So right now the x's don't eliminate. Negative 7y, negative 14y. You add those together, you get negative 21y. So right now, my x or my y, neither of them eliminates. So what we're going to have to do is we're going to use a little bit of multiplication here. We're going to either change one of my equations or we could even change both of them. So I'm either going to multiply the top, I can multiply the bottom, or you could even multiply both if you want to. And what I'm going to do is I'm going to use multiplication to try and get my variables to line up so that they will eliminate. So if I look at my x's, and I'll talk about there's two different ways you can approach this. I have a negative 1x and a negative 4x. So I'm trying to think, all right, what could I get negative 1 and negative 4? What number would they match up at where one's positive and one is negative? So you got to think, man, what would I multiply, say, this by, or maybe even both, to get them to match up? I bet I can get this top number to a positive 4, while this bottom number is already a negative 4. So if I multiply the top, I try and think, what can I multiply this by to get a positive 4x here? Because I already have a negative 4x down here. So if I have a positive 4x here and a negative 4x there, they would eliminate. So I have to think, what times negative 1 would get me positive 4? So what times negative 1 would get me positive 4? Might take a little guessing and checking the calculator, or you might just know your multiplication. Know if I multiply this by negative 4, I would get a positive 4 there, because a negative times a negative is a positive. 4 times 1 is 4. But if I multiply, I have to multiply the entire piece by it. So if I wanted to get rid of x, which we can go ahead and do that, we would multiply by negative 4. And the key is we're going to multiply the entire equation, everything there, by negative 4. A lot of mistakes is kids will only multiply the first part, not the last part. So if I multiply here, I'll show you what that looks like. Negative 4 times negative 1x is 4x. Negative 4 times negative 7y is positive 28y. And negative 4 times 14 is negative 56. That's the top line. My second line, we didn't multiply it by anything, so I'm going to leave it alone. Just rewrite it right here. So if you look at them, I now have a positive 4x, I have a negative 4x, which we should get our elimination there. Now before I continue on with the problem, I want to back it up and talk about what else we could have done in the original problem. So that's how we eliminated x's. If you wanted to eliminate y's, I have a negative 7y here and a negative 14y here. So you would have had to have thought about how can I get negative 7 and negative 14 to kind of match up, one being positive, one being negative. Well, I'd have a matchup, same multiple, which would be 14. This is already negative 14. Can't I multiply negative 7 by something to get positive 14? I sure can. If I multiply this by negative 2, I would get a positive 14y here. I have a negative 14y here. They would cancel out. But if I'm going to multiply by negative 2, remember you multiply everything there. Now with this example, I only show multiplying one of the equations. For pretty complex elimination problems, you might have to multiply not only the top equation, but also the bottom equation as well. So you're just trying to multiply to get the same multiple on top and bottom. That means the same number on top and bottom. Just make sure one's positive and one's negative. So back to our problem. I multiply by negative 4. I see that I have a 4x and a negative 4x. So I see exactly what I wanted. This is what I wanted to eliminate, and they will eliminate. If it doesn't look like your x or y will eliminate, you messed up with what you multiplied by. You need to go back and check it. So my x's will eliminate because 4x minus 4x is 0. It's gone. 28y minus 14y is 14y. Negative 56 plus 28 is negative 28. Solving this for y, just divide by 14, and we get y equals negative 2. So again, trying to find coordinates here, I found my y value, just got to figure out now my x value. So again, I could take this new piece of information, y equals negative 2, I could plug it into my top equation, I could plug it into the bottom. It does not matter which one you choose. I'm just going to use that top equation, negative 1x minus 7y equals 14. Take the y equals negative 2 and plug it in. So I have negative 1x minus 7 times negative 2 equals 14. So negative 1x plus 14 equals 14. And just pretty quickly here, solving for x, you would subtract the 14 over to the opposite side. That would leave us with negative 1x equals 0. And divide by that negative 1. And you're going to end up with x equals 0 divided by negative 1 is 0. So we get the solution 0, negative 2. We can take this, plug it in for x and y, plug it in for x and y, check and make sure it works. And that was solving a system of equations by elimination.